Good morning, all. It's my pleasure to welcome you all for the International Conference on Cloud Computing and Information Science, which is held at China. First, I would like to thank to the organizers for having inviting me as a keynote speaker for this conference. Actually, today we want to discuss about some of the pre-processing techniques. The actual title of my speech topic is Optimizing Facial Expression Recognitions through Effective Pre-Processing Techniques. Dear participants, we know that very well about the facial expression recognition techniques. The different kinds of emotions are produced by means of their emotions by a single person or a group of persons. What is the usefulness of the emotions which are created by individual or by group? What is the use of the emotions? How it will affect the individual's life and other individual characteristics? These things are actually analyzed in this research work. Now, the overview of this topic is we have to discuss the introduction first, then literature review, materials and methods which are used for this research work, followed by pre-processing methods. What are the pre-processing methods which are utilized for this research work, and experimental results which yield in this research work finally conclude. The conclusion we will discuss. As a first step of this facial expression recognition methodologies, what is called as facial expression recognition first? You should understand that it is a field of study that plays a crucial role in various human-computer interaction applications. So in between the computer and the human, there are a lot of applications are carried out. All these applications are utilized for the analysis of the real world problems, and the real world problems usefulness are also discussed during this conversation, and other activities are carried out by using some of the programming concepts. So that recognizing and interpreting human emotions from social expressions involves several components and challenges. As a first step, the pre-processing which is applied to every image with the aim of standardizing the images like scaling, blurring, rotating, altering the counter of the image, changing the color to grayscale and normalization. These are the basic steps applied when we find out some emotions and the expressions which are produced based on the human's face. Actually, the pre-processing in this research work, in general, we have to give the image as input data, and then some of the pre-processing techniques. Not all the pre-processing techniques are applied that we have already shown in the previous slide. Only some of the pre-processing techniques are applied in order to extract the features which are available in the facial expressions. And then finally, we can utilize some one or two machine learning models, machine learning algorithms to find and evaluate the facial expressions. So that it is essential to collect a large and diversified data set as input. To make sure that the model learns to recognize a broad range of expressions, it should cover a variety of emotions. Any images mostly contains some kind of emotions, any facial image particularly. Therefore, analyzing all kind of such emotional data is a tedious task. The gathered data are typically unorganized and originated from several sources by this research. So that this research collects some of the facial expression based data, and then it should analyze the emotions which are available in the facial expressions. For that, using the raw data is not useful. Therefore, it is required to pre-process the data. So the pre-processing data is mandatory. It must be standardized and cleaned up before given as input to the machine learning. Actually, the pre-processing is often employed to decrease complexity of the applied algorithm and to increase accuracy of the prediction. So after identifying phases by means of the several phases, I think this research work utilizes 10 phases, 10 people's phase expressions. So after identifying phases, the next step is to extract meaningful information or features from these phases that coordinate to understanding the emotions. Once the facial features are extracted, and then some of the classifiers or models are constructed in order to recognize and classify these features into specific expressions, such as whether the facial expressions are having emotions like happy, sad, anger, disgust, surprise, fear, and neutral. These are some of the very famous emotions which are produced by means of the facial expressions. Here in this research work analyzes all such kind of emotions without any hesitation. Actually, despite of the challenges, ongoing research and technological advancements continue to refer facial expression recognition methodologies, and such methodologies making them more accurate and applicable in various domains, which are from security to emotional intelligent applications. Dear participants, you may have some literature survey. For any kind of research work, it is essential to discuss some of the background papers based on the taken research topics. In this series, we have discussed one or two papers in this series. So in a research work, which is done by Loops et al., in which a facial expression recognition system was proposed that uses a combination of standard method like CNN, conventional neural network, and a specific image pre-processing technique which applied in this research work. The experiments carried out by them showed that the combination of both the spatial and intensity normalized procedures with the systematic synthetic sample achieved an accuracy of 92%. An accuracy of 92%, which was highlighted highest when compared to other pre-processing techniques, thereby increasing the accuracy. So another paper presented by Shin et al., in which the research work compares the accuracy of facial expression recognition system on 5 different types of input data, namely raw data and histogram equalization data, isotropic smoothing data, diffusion-based normalization, and difference of Gaussian methods. These are 5 methods, 5 different types of input data taken into account and which are analyzed. As a conclusion in this research work, that for the pre-processing method of the input image, the histogram equalization method showed that the most reliable performance in all the network models. Some of the network models are applied in this research work. So another work done by Fine et al., which proposes a new pre-processing algorithm with local binary pattern for facial expression recognitions. So that the complete face region is obtained in this work by using the cumulative projection. Then all the images are normalized by rotating the inclined faces, thereby removing the effect of high light resulting in desired facial input samples. So this research work achieved 72.75% of accuracy in predicting facial expressions. Also, The another work done by Zoe et al., which employs the independent component analysis, ICA, namely called. This is a technique in which the technique improves the performance of locally linear embedding LLE algorithm in facial expression recognition. This pre-processing is initiated by representing the face images by some independent components and filtering the noise from it. So the experimental research shows that the performance on the Jaffe database yield encouraging findings. The other databases are not effectively yield the findings. So next, we want to move the materials and the methods section. Usually, any kind of research work will not carried out by the researchers without using any methods, also without using any databases. So the databases which are replaced for this research work are discussed here, and then the methods which are replaced for this research work are also discussed in this section. So, but the major research topic in this facial expression recognition method is pre-processing. How we can pre-process the facial expressions in order to identify the facial emotions. That is the main category of this research work. So the facial expression recognition models are replaced, and then the models yielded results accuracy are also demonstrated. So that various image enhancement techniques such as noise reduction, contrast enhancement, image resizing, color correction, and segmentation are utilized in this research. Each technique has its strengths and limitations, and their effectiveness often depends on the specific application and the quality of the input image. Some of the cases, and in many cases also, a combination of these techniques might be used to enhance the performance of the system. The data set used for this research work contains the number of subjects, that means the number of persons is facial expressions, number of persons facial expressions taken for this analysis is 10 persons. Out of this 10 persons, 6 persons are female and 4 persons are male. They are in the age group of 9 to 10 years. Only we consider and taken the input data by means of collecting the facial emotions, expressions within the age between 9 and 10. So selected region of the data is India. Each and every image must minimum have 2 KB, and the number of basic expressions which are analyzed is 7 basic expressions are analyzed. So happy, sad, anger, just surprise, fear, and neutral. These are the 7 basic expressions which are going to analyze in this research. The nature of expressions are posed within the image itself. The nature of the expressions which are available within the image itself. The ultimate finding of this research work used to find what kind of emotions are accurately identified by means of this research work is the main concept. In a facial expression recognition system, 2 types of data sets are mandatory. One for training and another one for the testing. Testing or validation are both are same. So the data set for training the model must be large in number, but for the testing the model is smaller than the training data set. So the training data set and the testing data set are split into account and then which are applied for the pre-processing. So this research work utilizes the Python source code, especially in Python language, pandas and NumPy, matplotlib Matplotlib, and OpenCV. These are some methodologies which are applied in order to find the pre-processing, in order to find the expressions, facial expressions, in order to pre-process the facial expressions which are available in the facial emotions. So mostly resizing and converting the grayscale followed by normalization is the main work done in this research work. Dear audience, dear participants, you can see here, this is the original image taken for the analysis, which have 200 and 100 pixel range. After the resize the image, 50 and 50 pixels are both vertically and horizontally, which are carried out by means of this programming concept. And then the original image is going to convert into grayscale image. The pixel size is not differ from original image to grayscale image. Then in the normalized image also, there is no pixel size changes. But in the final image, the final image is the original output of the entire work, pre-processing work, which have a major modification compared to the original image, which have the 50 into 50 pixel concepts. So from the original image, the final image is obtained by means of this source code programming concept. This image is taken into account for the analysis. Actually, the stepwise pre-processing results are discussed. Here, the programming concepts used for this research work is, that is, the programming for the pre-processing is done in Visual Studio Code using the Python. The pre-processing begins with resizing the raw facial image to decide pixels, followed by converting the grayscale. In order to that is, we need to convert the image to grayscale. That is, image pre-processing operations works on one plan of image data at a time in grayscale, whereas in RGBA, the operations are applied on each of the 4 images plans, and then the results are combined. So that the grayscale images need to process only 1/4 of the data compared to the color image. This data reduction allows the algorithm to run a reasonable amount of time. The only drawback of this grayscale conversion of images is the loss of color information, which are not needed in recognition of the facial expressions. After converting the grayscale, the original image is normalized, where each pixel value in the range in the image is divided by 255. This will normalize the image values so that the range from 0 to 1 instead of 0 to 255, making the images more comparable and easier to process. Thus, normalization ensures that all the images have the same range of pixel values, which can make the training process easier for the machine learning model. Hence, both the training and the test data must be pre-processed to enhance the accuracy of predicting the emotions by the facial expression recognition models. So that next we have to discuss about the experimental results in this research work. The Python libraries such as OpenCV, TensorFlow, and GPU NVDA version 375.74 from NVIDIA's 375 is used. Why I have informed to this version of the NVDA are utilized for this research work means, if you utilize another another work, then the result vary. Therefore, the major work done in this research work is resizing, converting the image to grayscale, and finally normalization of the facial image. These 3 are the very famous work pre-processing method which are carried out in this research work. The result of pre-processing in predicting facial expressions is discussed in this section hereafter. That is, this is the original image which are captured, the pixel sizes and the other images quality are discussed in both the x-axis and the y-axis. After the pre-processed image, how the original image is changed and what are the different kinds of the image size and pixels, number of pixels are reduced. We can see very well effectively because the horizontal vertically 140 pixels are available, but in the pre-processed image only 60. Horizontally 100 pixels are available in the original image. In the pre-processed image only, which is in 60 pixels. Therefore, this kind of results yields very effective research conclusions. The raw facial image is input for pre-processing of this research. We can use the facial expression recognition techniques and the grayscale image resizing and the conversion of the color image to grayscale image are carried out in this work. Finally, the grayscale image is normalized, which enhances the performance of the FER system in accurately predicting the facial expressions. Dear participants, you have to see here the effect of different pre-processing techniques on accuracy. These are all accuracy. So the raw image have 89.01 accuracy for longer kind of the images, and for just 52.00, and for FER 44.23% of accuracy. For this, you can see here all these are all very, very important. After cropping and resizing, the percentage of the accuracy are improved, converting the grayscale and normalization. These three are the major techniques are applied. So this last row is the proposed method. In this proposed method, resizing, grayscale, and normalization, all these three methods are combined into a method. And then the yielded results of this proposed method is very high compared to the other methods. 100% of anger, and that is 100% of happy, 100% of surprise, and 94.27 and 94.43. You can see here very easily how many percentage of the accuracy are yielded by means of this proposed method. So this table displays the effect of different pre-processing techniques on the accuracy of predicting the facial expressions by the model. The 7 basic facial expressions considered for predicting by the model are anger, and already you know that very well about all this. The accuracy of predicting each class of emotion is very low when input facial images are pre-processed. Only when cropping and resizing is done with the accuracy of, that is, the accuracy of prediction fairly increases. After only converting the image to grayscale, the accuracy rate increases further. Therefore, performing only normalization as a pre-processing technique reduces the slight increase in accuracy. But the best accuracy rate is achieved only when all the 3 stages, namely resizing, conversion, and normalization are performed together in pre-processing stage. Therefore, the average accuracy of prediction of all the 7 classes of emotions is least when the images are not pre-processed. So that it is medium when the images are only converted to grayscale, and is the highest when the images are resized, converted to grayscale and normalized. So see here, this is the number of epochs. You know that what is called as epochs. The number of epochs start from 5 to 80. So actual training data set, training loss is decreased, and also testing loss, testing accuracy are also decreased. Whenever the number of epochs are increased, the images, the training and the testing images accuracy are increased. This is shown in this figure very effectively. You can easily understand from this figure the number of, whenever the number of epochs are increased, the training and testing accuracy are decreased. And then it is the accuracy of all these informations are carried. Therefore, the figure shows that after pre-processing the image, both the validation and training losses are getting reduced. This shows that pre-processing technique supports in resolving overfitting problems. This can be treated as a good baseline. When the epoch reaches 50, the training and validation losses have almost reduced. Therefore, it can be concluded that the prediction model is accurate and efficient. However, there is still scope for advancement in terms of attempting to eliminate the difference between training and testing errors. So a systematic strategy to further enhance the model would involve conducting a search for an optimized hyperparameter across the entire set of potential hyperparameters is the main point which we want to discuss and consider in this circle. The learning rate, batch size, number of epochs, and other parameters may all be modified to obtain the best possible combination. The huge requirement of computer resources is a major compromise in this search for hyperparameters. Therefore, the H params dashboard in TensorBoard provides several tools to help with this process of identifying the best experiment or most promising sets of hyperparameters. Here also, the number of parameters, number of epochs are based on the number of epochs. The training and testing accuracy are increased. But in this figure, the image sizes are reduced. But in this approach, the accuracy of training and data are increased. The image sizes are reduced, but in the final result, the training accuracy and the validation accuracy, that means of testing accuracy, are increased compared with the number of epochs. So this is the pictorial representation of this training and testing accuracy. Therefore, the table illustrates the training and validation accuracy. You can see very well about how the information, the accuracy is increased when the number of epochs are increased. So it is calculated using a separate data set called the validation set, which the model has not seen during the training. So the table shows a clear increase in both the accuracies as the epochs progresses. Therefore, in a similar trend, we also observe the validation accuracy reaching a value of 68.15 at 80th epoch from its initial value of 42.11. Therefore, the pre-processing techniques plays a vital role in increasing the accuracy of prediction, which is evident from the experimental results obtained from this work. So that we reach the conclusion, the final part of this research work. This research work proposes a facial expression recognition system in which 7 different facial expressions of different peoples from FER 2023 data set have been analyzed. Out of this 10 persons information, 6 are female and 4 are male. The captured facial images are pre-processed, from which the features are extracted and the CNN model detects the facial expressions. Accuracy is used as a metric to evaluate the performance of the system. This research test reveals that the accuracy of the model increases greatly when the normalization procedures are combined with the rescaling and the grayscaling. So according to the results obtained from this research work, this method provides a simpler solution and achieves higher accuracy when compared to the traditional classifiers that make use of the same facial expressions database. Further, training takes less time. In future, the same approach may extend to use utilizing the other approaches and other methodologies in order to get the clear-cut ideas, clear-cut results. Thank you very much. Thank you.